Hey, MMT followers, Christina Fuges with Moldmaking Technology, and today we're hearing from the Plastek Group and Triangle Tool in Erie, Pennsylvania about their imaging, augmented reality, and 3D printing initiatives.
So one of the biggest benefits that we have relative to sustainability is we have a large amount of pilot tooling, and we can use that to sample for our customers the different sustainable latest resins out there. So we're able to very quickly sample them, and sampling them in the pilot tool helps us understand not only the processability of the material itself, but then having that end product, we're able to test the functionality of it. So probably the biggest thing is those pilot tools and the ability to very quickly sample the different resins and get feedback immediately. Our pilot tools cut across a range of mold designs, so we can test the different mold design concepts, and then the end products, things like living hinges, how the material functions in living hinges, how it works with snapping features, unscrewing features, things like that. So that's probably one of the biggest benefits, having that, I'll call it a stable of molds ready to very quickly sample and very easily get the feedback from customers. Actually, one of the more interesting things that we're doing is we're sampling a 100% seaweed-based material. We're actually in the middle of doing that now, so that's an exciting thing we're working on for our customers. And then we just learned about one at the show here yesterday. There's a eggshell-based material that somebody's come up with, and it's used as a filler. So we're going to be processing that through our molds to see how that performs and see if there's anything there that can be of value to our customers. So when it comes to a mold design review, having the mold with you, with a group of the engineers around, having that augmented reality right there in front of you, and being able to walk around the actual mold as it sits on the floor in front of you makes the mold design reviews a lot easier. You don't have to look at a screen. That was the big thing, right? You got 3D on the screen, and that's really a cool concept when it comes to mold design reviews. But this is a step further than that. This allows everyone to kind of move around the mold as it sits in front of everyone on the floor. So it's probably one of the biggest things from a mold design standpoint that we're using augmented reality for. Still a little bit difficult to set up and use. I understand they're making some good progress in making it easier to set up and use. That's probably one of the biggest challenges, is getting it set up and ready to use.
When you're looking at it from either a sales or a project management perspective, it affords you a unique ability to transmit the cell as a whole to the customer, in addition to the mold, right? Where you have a spatial representation that you can tweak or modify if you see any obstruction. So it just assists you in putting together a viable solution, and it also affords you the ability to make changes quickly and effortlessly.
The other area we didn't touch on is training. So when it comes to us sending something, and if our customers can view it in augmented reality, they can pull the mold apart with their technicians or their engineers, and they can see it even before they get the mold. They can be manipulating the mold, and when we build and design molds, we send along a suggested preventative maintenance program, which includes how to tear the mold apart, how to get at different cores and cavities in there to maintain them. So if they have that even before they receive the mold, their engineers, their technicians, they can be trained on it already. The 3D scanner is still the mainstay for that, and we use it heavily, and it's becoming better and better. The ability to get a model quicker is becoming a lot more prevalent, and just the time to reverse engineer to it is really decreasing. So again, that continues to be our main tool to use there. Relative to 3D printing, that continues to improve as well. We're working with Exact Metal, who is a manufacturer of 3D printers that we have, and they're doing things with their software where you can change the power and the wattage during the same print, and you can get different different properties of that print within the same print. So you can have it a surface finish here that you want that's much finer.
For us, it also affords a unique opportunity to respond to customers quick. So if they have a specific issue that they've encountered, either with geometry or potentially flow issues, color variation, in some cases, and actually proven out, hasn't it, Doug, that we've been able to respond quickly to a customer by printing cores in a 3/8 scale that address this, and we were able to evaluate and solve those issues quickly. So again, it's all about customer expectation and exceeding those expectations quickly, efficiently.
I mean, customers are coming to us, they understand the benefits of conformal cooling. There were challenges, you know, in its infancy, trying to understand where you can use it and where it might be problematic relative to cooling. But I think the industry as a whole has learned how to really use it in conformal cooling, and our customers are aware of it, and we're certainly out there letting them know that this exists. And you know, the ones that don't, we bring that to their attention. So you know, that is a big part of 3D printing.